Welcome back, everyone, to the eCoreAcademy e-learning platform. Today, my name is AJay Raj, back with another geometry video for you all. Today's lesson topic is all about the triangle sum theorem. So we're going to be moving across our parallel lines and transversals and the different theorems amongst those. And we're going to actually be formulating different angle relationships and different angle theorems. We're going to be seeing these different proofs that are going to be coming across different triangle relationships and all of the triangle angles within triangles. So we're going to be looking at the triangle sum theorem, all of what it actually refers to, how it's going to be given in proof statements, and how it's going to be shown in different problems. And I'll go through that step by step when it comes to problems, and I'll be actually teaching you hands-on with what exactly the content provides in this lesson. Before we jump into today's lesson, please make sure to smash that subscribe button down below, hit that like button on this video, as well as turning on post notifications to get notified on any of our channel's latest posts at eCoreAcademy. All of those things are very greatly appreciated. As I was saying previously, the lesson purpose and topic of today, the whole theme of today's lesson is to discover what are the different types of angles given in a triangle. We know that we've already done previous lessons on polygons, and we've also gone over triangles extensively over triangles, all about the side length and angle classifications, to what exactly makes a triangle a specific type of triangle, coexistence, oblique triangles, area, perimeter. We've gone over the whole 9 yards, but now we're actually going to be getting into more complex relationships. We're going to be breaching that hole on polygons, because we're going to start from least amount of sides to a more numerous amount of sides, from regular to irregular polygons. And yeah, that'll be great, a lot of fun teaching and learning on both sides with the program we have here and the resources that we're given. So we're going to be discovering the different types of angles in a triangle, and we're going to be looking at, of course, what the relationships are. It's all about relationships in geometry, the heightened extensive concepts about it. So let's jump right into it. Let's look at polygons in general, because we know that triangles are a specific type of polygon. I'll just give you a very short review of what polygons are and a short triangular review before we jump into today's lesson with a lot more heightened concepts. I'm going to be throwing some things at you, so you need to really get a good grasp of the fundamentals. If you've already forgotten it, I'm just going to refresh you on it right now. So let's look at polygon qualification. We're going to be moving from generic to more specific. That's how we work here. So polygon qualification. So a polygon is a closed figure in a plane formed by 3 or more line segments, such that each line segment intersects exactly 2 others at their endpoints. So I'm sure many of you have already seen this definition before, at least not if you haven't in my videos, you've seen it before, heard of a polygon. So a polygon is just a closed figure. It's a 2-dimensional figure, obviously, and it's formed by 3 or more line segments. That's the least amount of possible line segments that you can have in order to actually close a figure, or develop a polygon, a figure. And it's created such that line segments intersect each other in at least 2 endpoints. That's a law of polygon. That's the only possible way you can form a polygon. So I'm going to show you some examples. Of course, you have, your square. One example we've already looked at. So your square, and we know different types of quadrilaterals, all the whole 9 yards. But we're just going back to basics. We of course have our triangle here, which we're going to be extensively looking at today. Of course, triangle sum theorem. It's in the title itself. So we have triangles here, vertices. Each line segment connects at 2 vertices, intersecting the other 2 line segments. Likewise, in squares, 2 different forms of intersection for each line segment or side. And then, of course, you have your rectangle here, 90-degree angles, equivalent opposite sides. And then maybe you're even familiar with a rhombus from my previous videos. It's a special type of parallelogram with all equivalent sides and no angle constraints. So those are 4 basic polygons. But today we're going to be extensively looking at triangles, and not just triangles, but we're going to be looking at different relationships created by triangles, and specifically angles of a triangle and all the different types of corollaries going with that. So let's jump right into it. So we're going to look at triangles as polygons. We're going to be moving away from polygons and getting more specific now. So a triangle is a polygon formed by exactly 2 other line segments intersecting an extended one, or 3 line segments in general. As I showed you before, any triangle, you have your right triangles, You have your right triangles here, which has one 90-degree angle and two acute angles. You have your oblique triangles. Sorry, not oblique, obtuse, I apologize. Which, have a giant obtuse angle and then two smaller acute angles. And then, of course, you have your acute triangles, which are all acute angles. All three acute angles. You can have equilateral triangles, scalene and isosceles triangles, all those different qualifications in coexistence. So these are the three types of triangles that are here. And all of them have common properties. They're all developed by two aligned segments created by one extended one, creating that ray or that angle, creating the angle through a ray or line segment, in this case, a line segment for a figure. So it creates the angle, the first angle, and then you're creating another line to develop the other remaining two angles. So let's look at the triangle sum theorem, different properties that it has, and the relationships that it will give. And let's look at a quick triangles review. So triangle, before we actually jump into identifying the triangle sum theorem and using its properties, let's look at triangle identification, because I'm going to be referring to that extensively. It's a much easier way of actually identifying triangles and basically communicating through paragraph format. So a triangle is a polygon with three sides, three vertices, and three interior angles, things that we already know, information that we've previously seen before, all alike with each other. So a triangle, say for example, we're given triangle ABC as shown here with vertices A, B, and C, which are the points in which the line segments intersect. That triangle will basically be called ABC. You're starting from your clockwise most point, and you're going to be moving around that figure. So we see A is towards the left most. We're going to be moving clockwise, so we see it's the form of A to B to C. So it's going to be a triangle ABC, and the symbol that we use for a triangle is basically a triangle, an equilateral triangle, ABC. So that's how you express it. And then it has sides AB, BC, and AC, as you can see here. You're just taking the very next units with each other. So A goes with B, B goes with C, and A goes with C. So you have sides AB, BC, and AC, and they're all defined by their vertices, which are points of the line. So you have, and that's indicated by lines like this: AB, BC, and AC. And you want to put that in alphabetical order of the vertices. And finally, you have those vertices that are created. You also have angles that are representative. Remember, an angle is always named by the vertex in which it emerges from. So as you can see here, we have three angles in this triangle, angles here. So we have angle A here, angle B here, and angle C. So that'll be indicated by this. This is how you represent an angle. So angle A, angle B, and of course, angle C. All right, now that we know triangle identification, let's get into the meat of today's lesson. So the triangle sum theorem, part 1. So let's look at the triangle sum theorem and its given parts so that we can fully understand it, and then let's actually utilize it in different case scenarios. So the triangle sum theorem states that the sum of the measures of the interior angles of a triangle is going to be 180 degrees. So that means the interior angles, all of the angles inside of the triangle, they're all going to add up to 180 degrees, something that you should already know. That's just another way of officially expressing it in geometry. And interior angles are any of the angles inside a polygon, specifically for triangles. So all the angles that are inside indicated by arcs without any lines emerging or extending out of the triangle itself. So, it's going to be indicated like this. So you're going to show any triangle, represent it. I'll use a right triangle here, just an example. We have this right triangle shown here. We have a 90-degree angle here, and then we have these other angles inside. So that's 3 angles formed, and the sum of these angles must equal 180 degrees. So that's this, this, and this. So triangle sum theorem part 2. Let's look at the corollary to triangle sum theorem. So a corollary is basically what uses the triangle sum theorem. It takes a process that is already implied, and it applies to a specific situation of triangle. So now that we know triangle sum theorem applies to any triangle, we're going to form a very specific statement corollary to that triangle sum theorem for a specific situation. And that situation comes with the right triangle. So the corollary to the triangle sum theorem states that the acute angles of a right triangle are going to be complementary. So if you're given a right triangle here, triangle triangle ABC, you can see that it has a 90-degree angle forming a right triangle. And we know that 90 degrees, it's going to be formed by 90 degrees, and we know that because of the triangle sum theorem, there's going to be 180 degrees minus 90 degrees, that 90-degree angle, because we know all right triangles have that 90-degree angle, so we can subtract it to get the sum of the remaining angles. And we have the sum of the remaining angles equaling 90 degrees. We know that complementary, so it says that acute angles that are complementary, so that means acute angles less than 90 degrees. So it's two angles less than 90 degrees that add up to 90 because of the values of A and B. And that's going to be true because minusing 90 degrees, you have 90 degrees left, which is the sum of angles A and B, which are the non-right angles. So that means angles A plus B plus angle B equals, let's just erase that. Sorry about that. So angles A and angles B added together equal 90 degrees, and that makes these two angles complementary and acute. So complementary, and if they're complementary, that means they automatically have to be acute. So write that down. So yeah, that's an interesting corollary. Triangle sum theorem part 3. Let's look at the parallel postulate. The parallel postulate is actually the form of proof for the triangle sum theorem, and I'll show you later on what exactly that relates to triangles. You might not understand it now. I won't explain it to you just yet because we have to get into triangle mid-segment theorems, these different triangle segment theorems, and then I'll show you exactly how the parallel postulate applies, but I wanted to get this out there first off. So you must know that the parallel postulate you must know the parallel postulate before understanding the previous proofs, and the previous proofs will also be added to the proofs that we'll learn later on. But the parallel postulate states that given a line and a point not on the line, there is one and only one line at the given point that is parallel to that given line. So I know that's very wordy, but I'll explain that here. So if you're given a line, we'll name this line, sorry about that, I'm just itching my eye. So we have line A here, and we have a point here. We're going to name that point C. And that point is obviously not existent on this line A. What they're trying to state is that only line that is parallel to there's only one line that's going to be parallel to point A that goes through point C, and that's always going to be true because of the specific location. So there's only going to be one possible line that'll pass through point C that's parallel to line A. And that very relationship can also relate to angles, meaning you can have similar angle measurements with the intersection in triangles and any figures in general. But I will show you that later on, and I'll do a whole example about that. Very important postulate here. So I would recommend writing that down or memorizing it, as you should everything else in this video, but this is especially important. So I'd recommend that you write this down, not just memorizing it. So let's look at the triangle sum theorem part 4. We're going to be looking at the types of relative angles under triangles. So we're going to be looking at angle relationships now. So two angles that share an adjacent side and whose other side extends in opposite directions form a linear pair. So if you have two different angles, one is an interior angle, one is an exterior angle extending in the opposite direction, those two angles will form a linear pair. And this linear pair forms a straight angle, which is 180 degrees. So we know that a straight angle is 180 degrees. And we also know that a linear pair will also add up to 180 degrees, which forms a specifically a straight angle in this situation. So what that basically looks like is if you're looking at a triangle here, as drawn here, and we're going to ignore these angles here. We're only going to focus on this angle right here. So I'm going to draw this angle here. What they're saying is if you take this bottom line segment and you extend it out infinitely, so you're just extending out in a line, what happens is you're taking this line, this angle here, say for example, this angle would be, let's say it's 60 degrees. Let's make this an equilateral triangle. So if this is 60 degrees, we know that this exterior angle here, this extended line here, this angle here, will form a crescent here, and that'll actually be 60 degrees. So these two angles will add up to 180 degrees, meaning this angle right here and this angle right here will both add to 180 degrees. So that means that you could use this value to calculate certain problems. So 180 degrees minus 60 would give you a value of 120 degrees, which is the value of this exterior angle right here, extended out with one line segment and specifically focused on one given line. And then let's look at the triangle sum theorem part 5. So types of relative angles in a triangle. Continued. So we have exterior angle of a triangle. We're going to look at definitions here. So the exterior angle of a triangle is an angle formed by one side of a triangle and the extension of another side of the triangle. Just like I showed you before. So when you extend a one side of a triangle and then you compare that, you create that angle completely adjacent to the interior angle given at that vertex. And then you have remote interior angle, which is all of the angles that is inside the triangle and is not adjacent to a given exterior angle, meaning that you can be given a situation in which an exterior angle is formed when one line is extended. These are the two remote interior angles because their lines have not been extended and they do not have a given exterior angle specifically given. Although they do have one that is existent, one is not given in this situation. But since this interior angle here does have an exterior angle automatically given by an basically an extended side length, that makes it a non-remote interior angle, just an interior angle. And this is your exterior angle formed out here. And then finally, triangle sum theorem part 6. Let's look at the types of relative angles in a triangle. Continued. And then finally, my next slide, I will show you what types of problems you're going to be coming across with this topic in mind, given this topic in mind. Sorry about that. So we have exterior angles theorem. So this theorem states that the measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior angle. So if you're given an equation here, say for example, the angle. So all it's saying is if you're given an exterior angles, the two other remote interior angles, meaning the interior angle that's adjacent to that angle, meaning angle 2, is not given. So it's saying that the exterior angle, like angle 1, given to the opposite remote interior angles 3 and 4, that it's the value, it's the sum of those two angles, and that's automatically assumed. So if we say that angle 2 is equivalent to, let's say, 58 degrees, so we know that 58 degrees is out of 180 degrees because we know that 1 and 2 are supplementary. They add to 180 degrees. So we subtract 180 minus 58. We get 122. So that equals 122. And after that, we can assume that this angle 1 is going to be 122 degrees. So angle 1 equals 122 degrees. And since we know that angle 1 is 122 degrees, and since we know that the sum of the interior angles of a triangle are 180 degrees, we subtract and see that 180 minus 58, which is the value of 2, will equal 122. Which shows you that 122, the value of the exterior angle, is also equivalent to the sum of 3 and 4. So angle 3 plus angle 4 equals angle 1, which is your remote. I'll abbreviate that. So it's going to be remote interior angles equals exterior angle. So yeah, that's a little abbreviation that I've shown here. And let's look at the different types of practice problems, and we'll end the video there. So the types of problems you're going to be encountering with the triangle sum theorem include finding missing angle measures of triangles with the triangle sum theorem, meaning if you know that a triangle has 180 degrees, you can say, for example, if you can find one angle measure, you could tell that you can tell the sum of those remaining two angle measures by subtracting it from 180. Or if you know that you have a 90-degree angle, you can use the corollary to tell that those two remaining acute angles are going to be equivalent to 90 degrees, and they're going to be complementary. You can also use the exterior angles theorem to calculate the relationship between interior and exterior angles, meaning you can extend these lines out. You can do it for all different angles. You can calculate their different relationships and discover unknown values, just like an algebraic equation. You can also describe relationships amongst different angle pairs, meaning if you have a right angle, obtuse angle, acute angle, you can calculate these different angles, see if two acute angles are congruent in any triangle. And that's given with the different concepts like coexistence and different types of triangles in general. And finally, you can always use these concepts in a two-column proof. You can use the triangle sum theorem itself in a two-column proof, and that's very important. You can use it to justify certain reasoning for why you subtracted certain values from 180 degrees to calculate missing angle measures in given triangles by using the triangle sum theorem in two-column proofs. All right, everyone, that'll be the end of today's video. This has been the eCoreAcademy e-learning platform today. Please make sure to hit that like button down below and smash that subscribe button, as well as turning on post notifications, the little bell below the subscribe button, to get notified on any of our channel's latest posts. Visit our website at www.ecoreacademy.org. All of our different subjects and courses are organized into course studies. Underneath subjects, we have all of our courses presented by myself and my sister, AJay Raj. And in those courses, we have, of course, all of our little perks added to our videos. So we have all of our organized videos. We have progress checks that gives you like a progress bar, like any professional online course would. We have different note sheets, worksheets that go along with, and worksheets that go along with each and every single video. We have different events given there, our contact information, and of course other perks and tricks that we're going to be showing you later on, different course material and different videos there as well, more extended content. And all you need to do is make an account for free, completely free. That's it. You can email us at eCoreAcademy@gmail.com. We, of course, have all of our information on our website as well, but you can email us at eCoreAcademy@gmail.com. We will respond to you as soon as possible if you have any questions, if you just want to reach out. Visit all of our socials. They're in the description box below at Facebook, Twitter, and Instagram. We have the links down there, as well as our email. See what kind of interesting content we have there. See what kind of new posts we have there, aside from our YouTube channel and our website. And of course, you can use that medium to share these videos to those who might need some help with the given topics, or those who might find it interesting. Once again, everyone, I hope you all enjoyed. This has been AJay Raj, and I will see you all in the next one. Peace.